Hi, everybody. Welcome to the Shuko Statistics Lecturing Series. And in this unit, Introduction of Probability. And now we're going to start our lecture number 4. And in the lecture number 4, we're going to talk about, we formally defined the simple space, the events, and some events operations, for example, union, intersection, complement. Also, we're going to introduce what we call this Venn diagram to help us to understand the relation for the, between the events. Okay, so now, for this lecture number 4, we're going to have 2 videos for this lecture. So the first video, we're going to talk about the definition about the simple space and the events, all right? Then after that, the second video, we're going to talk about the event operation, union, intersection, and the complements. Then we're going to talk about the Venn diagram. So for the first video, we're going to define what is the simple space, and we're going to define what is the event. Then we're going to work on 4 problems here. And then after that, for the video number 2 here, we're going to talk about event operations. So we're going to talk about the union, intersection, complement, and then we're going to work for a few problems here, and we're going to have another 4 problems for the video number 2 here. Okay, so that is the lecture number 4. We're going to formally introduce what is the simple space, what is the events, and what type of the events operation we can have. Okay, so for the video number 1, we're going to focus on the definition of a simple space and the event. All right, I'm going to go to the whiteboard and we're going to do a little bit of lecture, and then we're going to try to practice. All right, so let's start. And the simple space and the events here. So what is a simple space here, all right? So this is the, in order to find the probability, we need to know what is the simple space and how do we get the, what type of elements inside my simple space here. So the way we defined the simple space is a set, all right? So it's a set. And this set includes all the possible outcomes for your experiment, right? So those outcomes, you can call those, whatever the outcomes here, you can call this is the element. That's just some terminologies here, right? So you can call this is the elements. So the simple space is the set, and we typically use, the capital letter S to represent the simple space. All right, it don't have to, but that's kind of just a simple space. So we use S here. So let's take a look at what is the simple space, right? So we're going to find some simple example like in our lecture, and then we're going to work on the problems here. Okay, so the simple space we say is any kind of experiment, right? So then we said the experiment here. So let's say the first one I'm doing. First one, easy one. Okay, this experiment, I'm just going to flip a coin, right? So flip a coin, I will have a head and the tail. Those are the 2 possible outcomes when I flip the coin. So what is my simple space? So how do I write it? The simple space is equal to, you can write it as a head and the tails here. All right, that's what we mean the simple space, right? So let's take a look at example number 2 here. So we said instead of flip of coins, I'm going to flip 2 coins. Okay, so if I flip 2 coins, so the first coin can be head tails, right? Then the second point also can be head tail. So from the multiplication rule we discussed in our first video, we know total how many outcomes I'm going to have. I'm going to have 4 different outcomes. So that's why I can write my sample spaces here is what? I can say this is a head, tail, tail, head, right? So that means the first flip is head, the second flip is tail, or the first flip is tail, second flip is head. Or I can have a head, head, or I can have a what? Tail, tails, right? That's how do we define the as the sample space here. And then the next ones here, I can say is like, okay, so here, I can say I toss a die, right? So a toss die, so I know, the die is like, have 6 faces, right? So I toss a die, and then, my sample space will be what? Okay, so my sample space will be what? Will be 1, 2, 3, 4, 5, 6, right? So it's all the possible outcomes for my dice here, right? Okay, so now let's take a look more. Is interested here. Okay, so I flip a coin. Till I get a head. Okay, so now let's take a look at this sample space, right? So a flip a coin to here, I get a head. So what could be my sample space here? My sample space here, oh, I'm lucky. The first flip, I can get a head, correct? Or I'm not too lucky. So first flip, I get a tail, and then the second one, I get a head. And or the first 2, I got a tail, then the third time I get a head, and then I can go, maybe I never be lucky to get a head. So this sample space has how many elements? Infinite numbers of elements, right? So that's why we say the number of elements in a sample space here, that's what is this second sentence I want to talk about. The number of the elements in the sample space could be finite or infinity, right? So like for the sample space number 1, I have 2 elements. Sample space here, I have 4 elements. Sample space here, I have how many? I have 6 elements. And then number 4 is here, flip a coin till I get a head here, right? So till I get a head, and then the sample space is here is how many? So the number of the elements for this sample space is what? Is the infinity. Because I could be unlucky, I get a tail, right? So that's why when we talk about the sample space, it could have a finite or it could have infinity. Okay, so now the other things here, I said I'm interested here is, okay, so this experiment is, I said life of a battery. Okay, so the life of the batteries, so I know the battery could be the 2 hours, 3 minutes, or 3 hours, 4 minutes, and the hour is 2 hours, 4 minutes, 3 seconds, right? So the life of the batteries here. So for this type of the things, I know the life of the battery and the manufacturing give us say, hey, this battery can last, right? So if the last between, like 0 to 20 hours, right? So then for these ones here, my sample space here is I have a value. So the possible outcome, if I have these batteries, right? So a battery could from 0 to what? To 20 hours. So even like like the manufacturing says 20 hours, but I know the time, this is the measurements. you can say 20 hours, 1 second, right? 20 hours and 1 minute, 1 second. And then you can continue to that kind of divide the measurement units to the smaller and the smaller one. So it's not really like if I said 18 hours is this battery, it's not exactly the 18 hours. It could be 17 hours, 59 minutes, 59 seconds, and 1 nanoseconds or something, right? So your measuring is you can continue divide. So this type of the measurements. So we say that, inside the sample space, this type of the measurements is a continuous. Okay, so be careful, right? So that's why we also say it's discrete or continuous. So all the other 4 sample space, they are discrete because when I toss a die, I only can get 1, 2, 3, 4, 5, 6. I'm not going to get a reading, it's 1.5. When I flip 2 coins, right, I only can get a head, tail, tail, head, 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 tail, tail. So all those are discrete. But then for the number 5s here, this type of the sample space, because of the measurements, it's just because of our measurement gauges, like for example, the hour we measure to the seconds. But in fact, the time, you can continue to divide it into a smaller, and smaller units. We just don't use that. Right? But it is a continuous type of the measurements. So when we do the continuous measurements, that's why in the later lectures, we're going to talk about how do we deal with continuous measurements and how do we deal with discrete measurements, right? So for examples here, the typical continuous measurements will be, for example, your height, your weight, okay, the time take, times, right? And so those things, right? So those are we call this the continuous, so this is, we call this a continuous type of the measurements inside the sample space. And we do have a different way to dealing with that. So that's why I just want to mention here. So when you talk about the sample space, you could have a discrete or you could have continuous. Also, the number of the elements inside the sample space could have a finite numbers or could have infinite numbers. All right, so that we need to be careful. Okay, now the next things we want to talk about is events. Okay, events, we say, what is the events here, right? So events basically is a subset of your sample spaces here. So these events, based on the criteria, the subset, this based on the criteria. So based on what do you want, right? So everybody can define their own events here, correct? Okay, so that's what we call this event. And the event, typical, we use the capital letter to represent the event, right? So we can use the event A, event B, event C, just like we use the capital S to represent the sample space. It's not it's not like you have to use it. That's just like we typically use it. Okay, so let's take a look at the events here, right? So now let's take a look at the sample space. In number 2, I'm flip 2 coins, right? So we already defined it, right? So for example, I can define the event A. So remember, the event depends on what the criteria you want. You can define any events you want. Okay, so event A, I can say, I'm going to get at least 1 head. So like event A is here, say, hey, the things I'm interested here is at least 1 head, right? So that means I can write my event A is like this. I say, okay, at least 1. So that means it could be head and tail, and the tail and the head, or what, head and the head, right? Correct? All right. So that's why I said, so based on this criteria, also I can define the event B. I will say the event B I'm interested in is no head. So no head, that means my outcome, I'm only interested based on this criteria is no head. So what is my outcomes here? So this event is a telltale, no head, right? Okay, so let's take a look at for the sample space. Number 3 is here. Okay, so now I can define the event C. I say, I get an odd number. Okay, so for the simple space, number 3 is a toss dice, right? That's what our experiment. So it's a toss die. And the event C, I'm getting an odd number. So what is my event C? That means it's based on this specific requirement, criteria. 2. Oh, I'm sorry, it's odd, right? So, oh, come on. So it's odd. So this is 1, 3, and what? And 1, 3, and 5, right? Okay. So now let's take a look here, right? So the event is, let's take a look at the sample space. Number 5. So if I say I define the event, give any number, event O is like the battery lasts at least 12 hours. Okay, so I'm interested in the event O is my battery lasts at least 12 hours. So how do I write it? So I say O is equal to my X. Then my X has to be greater than 12 hours because the sample space is less than 20. So it's between 12 and 20, right? That's how do we define the event A and like how do we define the event O's here in this continuous type of the measurements here. Okay, now if you want, you can pause the video and go ahead and okay, so go ahead and pause the video and try, do it by yourself for this for those 4 problems here, right? And then to see you'll be able to get it or not. And then after you finish, resume the video, and then you can come here to check the answers here. Okay, so now if you want to pause the video, you can pause it and do the problems by yourself first and then come back here to check. Okay, so now let's start. Okay, so number 1 here is describe a sample space for the experiment which we roll what? We roll a pair of dice, right? We roll a pair of dice. So we know each die have 1 to 6, right? So the pair of dice, so my sample space, so if you want to write it, your sample space will be something like this, right? So you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? And then that means the first die is 1, and second die can be 1, 2, 3, 4, 5. Or the first die is 2, you can write it as 2, 1, 2, 2, 2, 3, 2, 4, and 2, 5, 2, 6, correct? So then you continue. So total, how many we expect? So it's 6 by 6, right? So it's 36 based on our multiplication rule. So you continue, you will give the 6, 1, 6, 2, and 6, 3, 6, 4, and 6, 5, 6, 6, right? So you can write this. So just physically write it out. Let's work, right? Or if you want to write it in a more mathematical way, because like if I say, if I roll 3 dice, that would be pretty difficult to write out all the combinations, right? So this is how we write the mathematical way. So we say the sample space is like this. it's going to be a pair, so it's going to be XY here, right? And what is the definition of the XY? So X has to be 1, 2, 3, 4, 5 to the 6. And the Y has to be 1, 2, 3, 4, 5 to the 6. So the XY will be all the combinations, right? So that's why we say it's 36. So if you write this way into the mathematical way, so, you know, when your sample space is getting bigger, it's easier to write, okay? Now, number 2 is here. They said, I'm going to roll in a pair of the dice. So we know here is our sample space from the problem number 1. Then the event B, I defined this specific event is to be the sum of the 2 dice. It's the 7th here. Okay, so that's why I'm going to find the B's, right? So the B is the sum of the, you know, the dice is 7. So I know the B is going to look like this. So that means you add X and Y will be equal to 7. So the first one is 1, 6, correct? Then the second one you can have is 2, 5. Then third one you can have is 3, 4. Then here you can have is 4, 3. Then here you can have is 5, 2. And here you can have is 6, what? 6, 1. So you know the event B has 6 elements here, right? Okay, so now let's take a look at number 3 here, right? So the number 3, they say if someone takes 3 shots at a target, the only thing we care is whether each shot is a hit or miss. Now I want to define the sample space about it. And then I have 2 events. I said event M is the person will miss the target 3 times in a row. And the event N will be the person will hit the target once and miss it twice, right? So how do we do this once here, right? So they say we only care is a hit or miss. So in here we can say, let's assume here, let's assume 0. You can give any letter, you know, so we said 0, this is a miss. And 1 is a hit, right? It doesn't matter, you can say M is a miss, H is a hit, right? Doesn't matter. I like to use the 0, 1, so maybe it's a little easier. So my sample space here, right? So in here, right, you shot 3 times. Each one is only going to have 2. So based on the multiplication rules, how many possible outcomes I have? I have 8, right? Because each one is hit or miss, hit or miss, hit or miss. Okay, so let's try to write down the sample space. So my sample space here going to be 0, 0, 0. That's why you can use a tree diagram we learned in the previous video to find it. Or, you know, so this will be 0, 0, 1, then the 0, 1, 0. Then this is the 1, 0, 0. And then you will have 0, 1, 1. Then you have 1, 1, 0. Then you have 1, 0, 1. Then you have 1, 1, 1. Okay. So then you have 1, 1, 1. So this will be your sample spaces here, right? Okay, now they said event M is a person missed the target 3 times in a row. So that means what is my event M here? 3 times in a row. So my event M only have 1 element, right? So it's 0, 0, 0. Okay. Now my event ends here is said, hey, is hit target once and miss twice. Hit target once and miss twice. So my event N going to have 0, 0, 1, 1, 0, 0, and the 0, 1, 0. Right? So my N has how many? My N has 3 elements, right? So hit once and miss twice. All right, so this one is kind of interesting. Okay, number 4 is here. So let's take a look at number 4. Number 4 is to say, construct a simple space for the length of useful life of a certain electronic component. Let the event F represent the component's fail before the end of 6 years. Okay, so like this one's here. The simple space we care is the length, the life, useful life for these components, right? So we know the length of the life is time. Time is a continuous measurements, right? Okay, so I can say here, I can define like my simple space this, right? So I will say, hey, the simple space is the time. What is my criteria is the time? Is the useful life. So that means is t is greater than equal to what? Greater than equal to 0, right? Because these electronic components, we don't know when it's going to fail. So that's why the t could go to infinity, right? So it's t greater than equal to 0. Okay, now the F events here, F event represented the component. It fails, right? It fails before the end of the 6 years. So that means, how do I define this events here? So it still is time t. So, but the t, has to be greater than 0. Fail before the end of the 6 years, right? So that's why t is less than 6, right? Before the end of the 6 years. So that is my event F here. I hope that you all got, you got all the problems correct. And that means you know the definition of the simple space and the events, okay? Because this will be the background we need for our next videos about how to find the events operations here, okay? So I will stop here because our video, so this is our video number 1. So I'm going to talk to you on the video number 2 about these lectures about the simple space and events here. Okay, so it's nice to talk to you, and hope you enjoyed the video, and hope you understand the concept of the simple space and events. It's nice to talk to you, and you have a good day. And looking forward to to talk to you on the video number 2 again. Okay, bye.